yesterday, we left off here that these are the basic rules that you need to know for electron configurations. All right. You do not have to define them, but you have to apply them. And the basic applications is you build from the bottom up. Everybody gets one. Everyone gets an electron, and no two can have the same. Just like street addresses, your house is different than your house. They're different street addresses, right? So our basic way to write an orbital diagram, you need to know electrons, they're represented with the up and down arrow. An up arrow means it's spinning to the right. A down arrow means it's spinning to the left. Right? So that's what you need to know. Don't be confused when you see up and down arrows, they're electrons. The energy level and its sublevel, which is our orbitals, those are represented by a line or a box sometimes. But most of the time, we are just going to use, all the time, we're going to use lines. Right? Energy does increase as you go up. Energy is increasing. Do we remember why S has one line?
Sphere, it's got only one.
What shape is it?
Sphere.
Sphere. It's a sphere. No matter how I turn a sphere in space, it's always kind of facing the same way, right? What shape is a P?
It's a dumbbell.
Dumbbell. So a dumbbell is horizontal, right? Or I can turn it vertical, or I can turn it in and out. So I can turn it 3 different ways in space. Does that make sense?
So wouldn't it be 3 then?
That's why P does have 3 lines.
Oh, okay.
P has 3 lines, because I can turn it 3 ways. Now that's whether it's 2P, or if I go ahead and as I keep building up, the 2 just means it's the second energy level. 3P is still going to have 3 lines, but now I'm at the 3rd energy level. I'm still dealing with dumbbells, but I'm at the 3rd energy level, all right? Because I keep adding on to my atom. As I go up in electrons, I keep having to add energy levels. Does that make sense? And then D, how many lines does D have to have?
4.
D, so like a 3D has to have 5. Because a D is, remember, a D, you don't have to know the shape of it, but it kind of looks like this, like a clover leaf. I can turn it here, right? I can turn it up and down. I can turn it in and out. I can angle it left or angle it right. So I can turn it 5 different ways. Okay? Does that make sense? So that's why D has 5. And then we basically apply the rules that govern electron configurations. So start at the bottom, work your way up, right? And that the easiest way to do it is just dive in and do some example problems. Okay? So let's go ahead and take a look here at an example problem. So we're going to use our rules for orbital diagrams. Orbital diagram notation, let's do nitrogen. Right? How many electrons does nitrogen have?
Let's look.
And we have this big periodic table here to look at.
7.
Nitrogen, how many electrons does it have?
7.
7, right? 7 electrons. So, I'm going to follow my rules. I'm going to start with my energy levels. I'm going to put them in the right order and represent electrons as up and down arrows, all right? Now, if you don't remember, all right, what do I start with? Remember this diagram we drew yesterday? 1s, 2s, 2p. What does this one have?
3s, 2p.
You should be able to create this on your own, all right? You should be able to do that on your own.
Do you do that 7 times?
Basically, yeah. For our class, we're going to stop at, and there's really F's over here, but we don't use F's. We're going to stop at 6s, all right? So, this, remember how to use this?
Yeah.
I start with 1s, so my first line is 1s. 2s. Next in line diagonally is what? 2p, 3s. And you just need to remember, S's get 1 line, P's get 3 lines, right? I'm going to stop there because I know I only need 7 electrons. How do I represent an electron? For our notations.
The up and down.
Up arrow, right? Everyone gets 1. I build from the bottom up, and no 2 can have the same spin. So if this one has an up spin, what's the other one have?
Down.
A down spin. How many can I fit per line?
2.
At max, 2, right? So 2 there, 1 up, 1 down. So I'm at 1 electron, 2 electrons, 3, 4. I need to get to 7, right? So I put 1 here, 1 here, and 1 here. All with the same spin. I don't double any of them up because I have to follow my rules. Everyone gets 1. They all have to have the same spin before I start doubling them up. And I don't double it up because I have 7. 1, 2, 3, 4, 5, 6, 7. I'm done. I don't even end up needing that 3s. That is the orbital notation for nitrogen. Okay? Questions about that? Okay? We're good? We can do another example. Pick, give me an element. Pick something.
Sodium.
Sodium, Na. Let's go higher.
Alright.
Platinum.
Yeah, PT, there you go. That's my favorite.
Yeah.
Right there. Platinum. Right? What do we got there, CJ, for how many electrons are in platinum?
78.
78.
Wait,
That's too high.
electrons.
Yeah.
There's only 1 through 8.
There we go. We'll do Fe. Good old iron. It doesn't fail us. Iron. I like the platinum, though, but that's a little too high for us.
Okay.
So we're starting at iron. Again, I'm going to follow my diagram, right? So, 1s.
These are some electrons in that too. There's 7 electrons.
26 and Fe.
Electrons?
In iron there is.
Electrons.
So I'm
Yeah,
right
there's
here,
26
3s,
electrons.
right?
I thought electrons were like the 1 through 8 thing.
Then, what comes after 3s? 3p, 4s.
Electrons are the atomic number.
Wait, what?
3p,
Bottom left hand.
4s. Now, I put them like a staircase because they are increasing in energy. You do not have to save paper. You can go straight across. But no, they increase in energy, right? So I'm at 4s. What comes after 4s? 3d, 4p, 5s.
That's gonna be nice in the video.
I know.
Just hear somebody.
Okay,
So bad.
so I'm going to stop at D because I know that's as high as we need to go. But it goes 3D, 4P, 5S. And I could continue building up depending on how many electrons I have. So I represent. I start at the bottom. I work my way up. Right? Is that okay?
No.
No, I cannot do this. I cannot put 2 in the same direction. So 1 up, 1 down. Yes.
Does it care? It doesn't matter like which if you start down then up.
No. Just as long as they're the same. Doesn't matter. Alright? I do it this way because I go up and then I come down into the down, etc. As long as they're up and down. So I'm at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Everyone gets 1. Then I can double them up to get to my 26.
How do you know when to stop, like going up on the 3D and like that?
You kind of get an idea of where to go based on doing it enough. Really, I knew to stop at 3D, and I'm gonna show you a shortcut next that actually teaches you if you can count to 26,
Yeah.
you can do this, and
Okay.
you'll know you won't have to necessarily know this order every single time.
Alright.
You actually just count on the periodic table. All right, it's different blocks of the periodic table. Good question. Yes.
So like, I don't understand, like, why are you not doubling it up after, like,
Why am I not doubling up here?
yeah.
I ran out of electrons. I only have 26. I'm at 26. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23, 24, 25, 26. The reason is I can't do for down here, 1, 2, 3, 4, 5. If this was 3D, I can't do 1, 2, 3, 4, 5, 6, and leave 2 blank. Everyone has to get one. So I got to be fair. So I put 1 there, 1 here.
Oh, okay.
All right? That makes sense?
Yeah.
That's that rule you have to follow. Okay? All right. That is orbital diagrams. Okay? What we can do with orbital diagrams is make our lives a little easier and actually draw the electron configuration off of those. Okay? So it's like a shorthand. All right? So from orbital diagrams, I can do a shorthand electron.
There we go.
Configuration. That's a shorthand notation. Electron configurations. All it says is represent the electrons as an exponent. So, for nitrogen, which is number 7, I'm going to write the electron configuration of nitrogen, right? It's 1s. How many electrons are in the 1s orbital?
2.
2. Represented as a exponent. 1s2.
Oh,
2s.
2. Makes so much more sense.
Makes sense, huh?
Yeah.
Then what? 2p.
3.
3.
I got it.
Right? Does that make sense? Do we see that? So if we did... If we wanted to do the electron configuration of iron, electron configuration, what would that be? And we kind of lost those here, right? But this was 1s, 2s, 2p, 3s. What would that be? The electron configuration of iron.
1s to the second.
1s2,
2s2. 2p6. 3s2. 3p6. 4s2. 3d. Oh, 5.
3d,
6.
6.
Count.
1, 2, 3, 4, 5, 6. That's the electron configuration of iron. Does that make sense?
Yeah. Yeah.
Okay?
Then the. Oh.
Now, there is a shorthand to this. You want to learn the shorthand, the shortcut? If you can count to 26, you can get the electron configuration and the orbital notation, and you don't have to follow this every single time. Okay? Now, that is where your blank periodic table comes in.